Okay, so now we do question 3. Lansing, Michigan has a population of 113,972. It's remarkably close to Ann Arbor. A rare disease affects 40 people a year in Lansing and 20 people a year in Ann Arbor. So what are the sample proportions for getting the rare disease in Ann Arbor and Lansing respectively? Okay, so we can just calculate that. It's very simple. It's just the number of affected people divided by the total number of people in Ann Arbor or in Lansing. So if you do this, you get for Ann Arbor, a number of 0.00017, and for Lansing you get 0.00035, about double as high. Okay, and then you do the 95% confidence interval. What you just do is you just take those sample proportions, and then you do plus minus 1.96 in both cases times the standard deviation. Okay, and the standard deviation here is, just looking at the notes, standard deviation of the sample mean is the square root of the p for Ann Arbor, the sample mean, sample proportion times 1 minus p divided by the number of people in Ann Arbor, and you do exactly the same thing for Lansing, PL times 1 minus PL divided by the number of people in Lansing. Okay, and then the solution show you the numbers. I don't write them down because they're very small. I probably make a mistake, but it's basically just you can just copy this essentially from the notes. Now 3b asks you to do the same thing except for an 80% confidence interval. That's an unusual confidence interval. So how do you but the only difficulty is to calculate the equivalent of 1.96. 1.96 is, if you remember, 1.96 comes from Q norm of 0.025. Okay, so we're asking at what point is the area here under the distribution exactly 2.5%. And if you do this on both sides, you get 5%. So if you want to get the same for 80%, then all we need to do is we just do Q norm instead of 0.5, we do Q norm of 0.1. Okay? And so we do the 10% tail on this side, the 10% tail on the other side. And Q norm of 0.1 is minus 1.28. Okay? So instead of having plus minus 1.96, we have plus minus 1.28. Okay? And that gives us the 80% confidence interval. And the question then asks, is this interval smaller for 80% or larger? And the interval is smaller. Why is that? So that requires a little bit of thinking. But the idea is the following. The confidence interval tells you what is possible. What is possible with some probability, where can the true population mean lie? Okay, so this is the true probability for Ann Arbor and Lansing, respectively, to get sick. Okay, so we calculated here the 0.00017, 0.0035 are the sample proportions. Okay, that's not the true probability for Ann Arbor and Lansing to get sick. But the confidence interval tells us where the true probability lies. Okay, usually with 95% probability, but we also calculated the 80% probability one. Now, if we only have to be 80% probability, if we only want to be sure with 80% probability where the true parameter lies, we can give a tighter interval. Okay. Now, this guess will more likely be wrong than the wider interval, but we only have to be this time 80% right rather than 95% right, and that explains the difference. Okay?